Welcome to a lesson with Dr. Powell. Let's take a look at the statement of the law of quadratic reciprocity. It says that if you take two primes, and we're going to assume that these primes are odd, so neither of them are two. Um, if we take q and think of it, is it a square mod p? That's what this statement says. And if it is, it's equal to 1. If it's not, it's equal to -1. So this is a statement that Q is a square mod P, um, if and only if P star is a square mod Q. Now P star is simply equal to this product, -1 of the P minus 1 divided by 2 times P. Now if you notice, if P is congruent to 1 mod 4, then think of this top being like, so think of the top as being in mod 4. If you put 1 here, that would be like 0 mod 4. And 0 mod 4 means it's, there's like a 2 times its multiple of 4. So if you divide by 2, you're going to have an even number, and this is going to be positive. So in other words, when P is congruent to 1 mod 4, P star is positive. In contrast, when P is congruent to 3 mod 4, see what happens. We get that this is 3 minus 1, so that's the top will be like 2 mod 4. And something that's 2 mod 4 divided by 2 is actually an odd number, which means we have a negative P. So this is just another way of writing P star. But this is the statement of quadratic reciprocity right here, that if you take a prime Q, it's a square mod P exactly when P star is a square mod Q, and no other time. So if it's not a square, then this is not a square. If that's not a square, then that's not a square in that case. Okay, so we're just going to make, in this little video, we're just going to make some comments about this statement and maybe a couple other equivalent statements. No proofs in this little video, just some comments. So here, note that -1 being a square mod Q happens if and only if Q is congruent to 1 mod 4. So why is that? Well, thinking about this, okay, well, if you take Q minus 1, Q minus 1 is the order of the multiplicative group mod Q, and this multiplicative group mod Q is cyclic. And if Q is congruent to 1 mod 4, then Q minus 1 is divisible by 4. And so we have a cyclic group whose order is divisible by 4. And we know the cyclic group that there's a unique element of order 2, and that's -1. But there's also, so that means that a -1 definitely has a square root here. It has to, it's forced to, because it's the unique one of element of order 2, and we have elements of order 4, and they have to, if we square those, we'll end up getting an element of order 2. So, so this is just one little thing to keep in mind here in our statements, is that -1 is a square mod Q, if and only if Q is congruent to 1 mod 4. In fact, if Q would not be congruent to 1 mod 4, so the cases we're taking odd primes, so it's either 1 mod 4 or 3 mod 4. So if it's 3 mod 4, then then Q minus 1 is congruent to 2 mod 4, which means -1, since it's order 2, it can only be a square if there's an element of order 4 in there, and there won't be, since 4 doesn't even divide the order here of that multiplicative group. Okay, so this is an if and only if statement. Okay, so there's different formulations of the law of quadratic reciprocity, and in essence, they have to do with with this product right here. Q mod P, or is Q a square mod P versus P a square mod Q, and multiplying these two ideas together. In fact, let's just kind of go forward a slide to see kind of where we're after. If you multiply these two guys together, so either -1 or +1, we'll end up getting this. So let's discuss why that is so. All right. I mean, I guess there's little proofs but in here, but it's just all having to do with the statement of the law, so nothing really much or heavy. Okay, so let's take a look at this. Let's look at a couple of cases. When P is congruent to 1 mod 4, all right, then that means that P star is positive P, which means that if this is +1, then this is +1, so of course that product's 1. If this is -1, then that's -1, since it's an if and only if, because P is equal to P star in this case. And so this is always equal to 1. But also, if P is congruent to 1 mod 4, then P minus 1 is 0 mod 4 divided by 2. That's an even number. That's always +1, which means that in this, so in the case when P is congruent to 1 mod 4, not even paying any attention to what Q is, we end up getting that this thing right here is equal to -1 to the P minus 1 over 2. It's just equal to that. And let's see here. Right. Okay, so -1. Right. So this is equal to pot. So in the case when P is congruent to 1 mod 4, we end up getting that this product is equal to -1 to the P minus 1 over 2, which is simply just +1. I mean, this product is always +1 in that case. So if this is +1, raising +1 any part is +1 still. So we're good in that particular case there. Okay. Now let's look at the case when P is congruent to 3 mod 4. Split this up into a couple different cases. One, when Q is 1 mod 4, then that means that -1 is a square. Okay, so let's suppose that Q is a square mod P, then P star, which is negative P in this case, is a square mod Q. And since -1 is also a square, their product to positive P is also a square, which means that that this is 1 and that's 1, so that's +1. Now, in the case that Q is not a square mod P, so -1 in that case for this guy, then that means that negative P is not a square. Now think about that. Negative P is not a square, and right, so negative P is not a square, and we also know that -1 is a square. So if -1 is so multiplying something that's a square by something that's not a square, especially if you think about exponents of a primitive root mod Q, like even plus odd, you still have odd, so it's not going to be a when the exponents, it's not going to be a square. So P is not a square mod Q. So we have both of these as -1s if product is +1. So in this particular case right here, so when P is congruent to 3 mod 4 and Q is congruent to 1 mod 4, we end up getting that this product will be +1. Now let's look at the next case right here, case 2. When Q is congruent to 3 mod 4, that means that -1 is not a square. We just discussed that. So when it's not a square, then that means that that if Q is a square mod P, and okay, so we know, so if Q is a square mod P from the statement of quadratic reciprocity, then like we had at the beginning, then negative P, which is P star, has to be a square mod Q. So both of these are 1. And you know, so you know this is a square, and you know that -1 is not a square. So you have something that's not a square times something that is a square. Again, for a similar reason from what we had before, that would tell you that P is not a square mod Q. So this is 1 and this is -1, so the product is -1 in that case. Now let's look at this. Now let's suppose that Q is is not a square mod p. All right, that means that p star is not a square mod q. P star is negative p in this case. So negative p is not a square. Negative 1 is not a square. Their product is like an odd exponent plus an odd exponent, which is an even exponent, meaning their product actually is a square. So that means that p is a square mod q. So q is not a square mod p, so that's negative 1, that's a positive 1. Multiply them together, you get negative 1. So let's put these ideas together. If p is congruent to 1 mod 4 or q is congruent to 1 mod 4, so this case or this case, we end up getting this product as positive 1. That's the same thing as saying that one of these guys, p minus 1 over 2 or q minus 1 over 2 is even. Since 1 mod 4, that's like 0 mod, so multiple of 4 divided by 2 or a multiple of 4 divided by 2 here. So one of those is even. All right, in that particular case, that's what we were just looking at, p mod 1 mod 4 or q congruent to 1 mod 4. So in either one of these, we end up always getting positive 1. Now, in this case, when we have so otherwise, we actually have both of these guys happening. P is congruent to 3 mod 4 and q is congruent to 3 mod 4. So remember, the only times we had negative 1s was in finality down here was down in where we had both this and this happening. Okay, that means their product is negative 1. That's the same thing as saying that both of these guys are odd, which means that their product is odd. If their product's odd, then you multiply them together, you're going to get negative 1 to an odd power, so it's going to be negative 1, right? Now, if just one of these guys is even, though, then you're going to get a positive 1. So really, we can make our statement of the law of quadratic reciprocity in this way, that the product of q being a square mod p and p being a square mod q is simply negative 1 to this product right here, p minus 1 over 2 times q minus 1 over 2. So that's just another way of stating the law of quadratic reciprocity. Thanks for watching.